Standard 12 Chemistry, Unit 9, Coordination Compounds, Part 4. Here we discuss about the IUPAC nomenclature of coordination compound. For the nomenclature of coordination compound, we have to follow some rules. Here, the basic concept. For example, it is written in square bracket in central metal atom, and after that it is ligand Cl2 square bracket over and Cl. So between central metal atom and the ligand there is no space. So for example, here the no more spaces between ligands and central metal atom. Okay, and then after the ligand written in alphabetical order, here the ligand is amine and here the chlorido ligand. So as per alphabetical, amine will be first, so this ligand written is first, and then after chlorido ligand is written. Here the same complex is written COCl2 NH3 4 times, square bracket is over, and Cl. So here this is not in alphabetical order. C stands and there, and here the for amine is A, so it is not in alphabetical order, so this kind of complexes or written is completely wrong. And then after the Cl2, this subscript or here for on upper side of the square bracket, or it is said to be as superscript. So some important neutral ligands are NH3, it is amine, H2O stands for aqua, CO stands for carbonyl, NO nitrosyl, CH3 NH2 methanamine, and its IUPAC, and the ligand name is same for methanamine. Now this some anions or negative ions ligands. And their charge stands for -1, and their suffix is O. For example, here X stands for halide ion. In case of ion, it is named as chloride ion, but here in case of ligands, it is named as chlorido. Br minus bromido or bromide, and E is replaced by O, so it is named as bromido. I minus, it is named as iodido. F minus, fluorido. OH minus, it is hydroxide ion, but in case of ligands, it is named as hydroxido. Cn minus, in case of anions, it is named as cyanide ion, but in case of ligands, it is named as cyanido. Here the NO2 minus, it is nitrite ion, but in case of ligands, it is named as nitrito. N, or it is written as ONO minus, so it is nitrito O, because here the electron pair donor is O, so that's why it is named as nitrito O. And here in case of NO2 minus, the electron pair donor is N, so it is named as nitrito N. In case of thiocyanide ion, it is named as thiocyanato S. Here the electron pair donor is S, or NCS minus, and it is named as thiocyanato N, because here the electron pair donor is N. Then after, the negative ions which has -2 charge, it is CO3 2 minus, it is carbonate ion, but in case of ligand, it is named as carbonato. Then after SO4 2 minus, it is sulfate ion, but in case of ligand, it is sulfato. C2O4 2 minus, or it is written as in short OX, it is oxalate ion, but in case of ligand, it is named as oxalato. Here in case of -3 charge, PO4 3 minus, it is phosphate ion, but in case of ligand, it is phosphato. Now the first type of complex as ion, complex as anion or negative ion, M plus. Here the metal and ligand, and N minus charge. So in case of this first tip is metal and metal atom or ion is written like, so suppose it is sodium ion, so it is directly written as its regular name is sodium. In case of potassium ion, it is written as sodium, potassium only. For NH4, it is ammonium Fe2 plus is ferrous or iron, but its charge is plus 2 because it has two different valency. And in case of Fe3 plus, it is ferric, or it is named written as iron 3. So normally this is the first step we have to follow, and then after, in the second step, we must return their ligands. It is second step, and the ligands written as per alphabetical order. Is the second step, and now the third step is metal ion or atom with oxidation state in a Roman letter. So first step, metal atom or ion is written. In second step, ligand written as per alphabetical order, and then after the third step, metal atom or ion with oxidation state in a Roman letter, and their suffix is at, at. For example, V for vanadate, V for vanadate, C for chromate. So here the Cr is chromium metal, but in case of the metal atom or oxidation state with their Roman letter, chromate, and then Mn, it is manganese, but with at suffix it is manganate. Fe for ferrate, Co for cobaltate, nickel for nickelate, Cu for cuprate, zinc for zincate, Ag for argentate, Au, this gold, or its name is aurum, but it's written as aurate, and Hg for mercury, it is written as mercurate. Now the steps to be followed for IUPAC nomenclature. First step is write common positive ion, or it is metal atom or ion, Then second step is write ligand in alphabetical order. Number 3 is metal ion, is metal ion name with at suffix. And the fourth step, write the oxidation state in Roman letter. For example, here the metal atom or ion, and then metal ligand square bracket over charge, this type of compound, coordination compound. Number 1 is K4 is metal potassium metal ion, then Fe, and the ligand is cyanide, Cn minus cyanido. Now we have to find the oxidation number. Here the 4 plus 4 Fe is metal, and for cyanide it is 6 minus, and their total is 0. So 4 minus 6, so it stands for plus 2 oxidation state, this central metal atom. Now the name is, in first step, write common positive ion, that is metal atom or ion. Here the for potassium, K for potassium. And now the in square bracket the ligand name. Second step is ligand as per alphabetical order. Here the ligand is only one, so it is 6 times, so it is written as hexa. For Cn, cyanido, hexa cyanido. And in third step, metal ion name with at suffix. Here the ferrous, and it is with at suffix ferret. It is ferret, and its oxidation state is plus 2 in a Roman letter into bracket 2. So it is named as potassium hexacyanido ferret 2. Second example, K3 FeCN 6. Here the charge for potassium 1 and into 3, so plus 3 minus 6, so its charge will be plus 3, stands for 0. So it is named as potassium hexacyanido. For ferrous it is named as ferret. Now its oxidation number is 3. It is in Roman letter. This is the only difference between two complexes, and their oxidation state is different. Then number 3, NH4. NiCl4. Here NH4 twice, NH4 twice. The oxidation state is +1 for ammonia, and here the +2, it is +2. Then after it is nickel, and for chlorine 4 minus. Here the -4 equal to 0. Therefore +2 minus 4 is -2. Therefore oxidation state is +2 for nickel. Now the nomenclature is it stands for ammonium, then tetra for Cl, chlorido for nickel, nickelate, and in oxidation state is 2. Now the fourth example is Na2 Cr Br4 CO twice. Now first of all, we calculate the oxidation state of chromium. Here the twice Na plus Cr plus 4 Br plus twice of carbonyl and equal to 0, plus 1 plus Cr, here 4 and -1, and for carbonyl its oxidation state is 0, plus 2 plus Cr minus 4 plus 0 equal to, therefore Cr minus 2 equal to 0, therefore Cr equal to plus 2. Its oxidation state is plus 2. Now its name, here the metal and its common name is sodium. Now we have two different type of ligand. It is bromido and it is carbonyl. It is neutral ligand. B stands first as per alphabetical order, so it is named as sodium tetra bromido. Then dicarbonyl, 2 times carbonyl, so it is dicarbonyl. And then after for Cr it is chromate, and its oxidation state is 2. It is named as sodium tetrabromido dicarbonyl chromate 2. Then next example is K3 Cr OX 3 square bracket over. It is oxalato ion, OX for oxalato ion, or it is C2O4 2 minus. Here the for potassium plus 3 charge, here the Cr, and here the -6, because here 3 into -2 -6 0, so its oxidation state will be +3. Now name, its common name is potassium. Then after 3 times oxalate, so it is named as per ligand oxalato. Ligand is trioxalato. Then Cr for chromate, and its oxidation state written in Roman letter 3. Potassium trioxalato chromate 3. 6 is NH4 CO NH3 twice OX twice. Its oxidation state +1. Here the cobalt, and here the 0 oxidation state, and -2 -4 and 0. So +1 -4 -3, its oxidation state is +3. Now NH4, it is ammonia, it is oxalato for O and amine for A. So as per alphabetical, it is written as diamine dioxalato cobaltate, CO for cobaltate, and its oxidation state +3. Then next is sodium Na AgNO2 twice En twice. Here the +1 is AgNO2 minus, it is 2 minus 1 equal to -2, and En for 0. So -2 plus 1 -1, so we need to balance for +1. Now name is sodium, and then ethylene diamine. But here in this case, whenever the ethylene diamine, it is named as bis, because here the 2 times ethylene diamine, if it is 2 times, it is named as bis, or 3 times, it is named as tris. So it is named as bis, or here into bracket ethane 1,2 diamine. Sodium bis ethane 1,2 diamine, and then dinitrito N, dinitrito N, Ag for argentate N. Sorry, here the argentate, and its state is into bracket is 1. Sodium bis ethane 1,2 diamine dinitrito N, argentate 1. Next K2 Zn OH 4 times. Here the +2 zinc is X, and here the -4, it is +2. Potassium, then 4 times, it is tetra hydroxido Zn for zincate, and its oxidation state is 2. Potassium tetrahydroxido zincate 2. Next is HgCO SCN 4 times bracket over. Here the mercury and its oxidation state is +1. Here the +1, and then cobalt cyanide for -4, 4 minus 1 minus 4, so it is for cobalt oxidation state will be +3. So mercury 1 tetra thiocyanato S cobaltate 3. Next is Fe4 FeCN6 thrice. Sorry, here CN6 only. The +8 and here the -6, so it is +2 is iron 3 hexacyanido Fe ferret 2, and the next is K2 PdCl4. Here the +2 Pd and -4, so it is +2 is named as potassium tetrachlorido Cl for chlorido palladium, and its suffix is at, so it is named as palladate 2. Okay friends, this is the one type of IUPAC nomenclature of complex compound. Next time we will discuss the another type. Thank you very much.